We have about Benjamin Pearl tell us about studying the high multiphase environment surrounding NGC 1275, the Citel, Escadales, high spectrum resolution.
Well, hi everyone. I'm Benjamin Vigneron, PhD student at University of Montreal, and today we'll sort of explore together the optical filaments that surround NGC 1275 with both Citel and Espadon's high spectral resolution observations. So, just to start things off, NGC 1275 is what is known as the central brightest cluster galaxy of the Perseus cluster. So it is really a massive, luminous, elliptical galaxy, and when observed in the optical world, this is what you see. An extended filamentary nebula binary gas emitting strongly in H-alpha and reaching almost a staggering size of 100 kiloparsec. So you'll learn more about these filaments and these structure in Marie-Lou Gendron-Marcellus talk tomorrow morning, so stay tuned for this. But Citel was used a few times to observe this structure. First, back in 2018, with observation at moderate spectral resolution. But it was really a breakthrough at the time because it allowed for the complete mapping of the entirety of the filamentary structure. So the data was analyzed by Marie-Lou, and she produced this small video that allows us to better see. So we're essentially stepping through the Citel spectra, and you will see the filaments flare up once we reach the main emission lines of the filaments, namely ionized nitrogen and H-alpha here. Yeah, it doesn't show really well on the projector. But we then have what is known as the high velocity system, which is essentially just a full galaxy that is falling onto NGC 1275. And then we have the ionized sulfur emission lines right here. But Citel was used yet again at a much higher spectral resolution to observe these filaments, and we could obtain new flux, velocity, and velocity dispersion mappings of these filaments. So first, with the flux map, you can see that we have a sort of dichotomy between the central structure that is much brighter, that has a much higher flux compared to the outer filaments that are much fainter, but around an order of magnitude. We then have the velocity map, and so in that case, most line of sight velocity. As you can see, we don't seem to observe any trend or pattern. The velocity is more so chaotic in the sense that going from pixel to pixel, you can have huge jumps in velocity. And finally, for the velocity dispersion, yet again, we seem to see a central structure that has a much higher velocity dispersion compared to the outer filaments that appear more quiescent. So we were really interested by this central structure and trying to see if we could decipher or disentangle multiple velocity components within it. So we spent some time scouring CFHT's archive and discussing with Ned and Marcel. We were made aware that back in 2015, there was some Espadon's, strangely, observation of several pointings within the filaments. Now, these observations were kind of left to the side because most of the pointings could not be properly observed, but one of them, targeting the central structure really close to the galaxy, was actually a treasure trove of spectral information. So here is the Espadon spectra, focusing on the main emission features, so N2 and H-alpha. And you can see that the most efficient fit that we can obtain is a three-component fit with a really narrow component that is really reminiscent of what we can observe for the outer filaments. We can then see that we have a slightly broader component, really similar to what we can observe for the central structure. And then a third really, really broad component, which most likely is some leftover AGN outflow since the pointing is really, really close to the central galaxy. Now with Espadon's, we can also obtain polarimetric data. So we can see that both in Stokes Q and U, we have features that are associated with these main emission lines. But we are still on the early steps of analyzing the polarimetric data. So if you have any insight or wish to discuss this, we're more than willing to chat and discuss these data. So thanks, and I can take questions.
Questions?
Thank you. I'll be showing you first.
Oh, yeah. So these are U, and so U on the left side and Q on the right side for the same pointing. Sorry, it was? It
all signs of the side of.
Oh, well, technically those are, it's actually a great question because we don't really know specifically how these main emission lines, what is the source specifically of ionization. So it could either be by the AGN activity or by the surrounding. So these filaments are sort of embedded within a really, really hot plasma emitting an X-ray. So it could also be a source of ionization that way. But yeah, we are not specifically sure on the source of ionization of the filaments. So I can't answer you for certain on the source.
Great. Thank you very much.